we get C also. So these 2 hours, I will zoom in and out, zoom in and out. Okay. Now 2A plus B. Okay. Now 2A plus B is more trickier because in order to get C now, you can see wow, 2 of A, 2 of A together with B. Imagine this 2A and B, it must collide each other in order to produce C. Okay? Therefore, the rate of disappearance of A now, it will be K times CA squared times B. This is to indicate that this rate of reaction, it will depend on the concentration of Ca. So this is representing 2Ca, right? Okay, so for this, when we see this equation, when you see this equation, you should know how to draw the rate of reaction already. Okay, you must be familiar with this already. Because more and more we are going to use this. Okay, so for now, cut it short. If we have this is so-called like standard equation between reactant A plus reactant B. So basically reactant A plus reactant B, the rate of disappearance of A, okay, will be K times Ca alpha Cb beta. So where this alpha is coming from, this alpha, it will be from the coefficient here. And at the same thing, beta, it will be from here. Okay, this one I think easy, Telling, right? So this is the general rate of disappearance of reactant A. So the rate of this equation, we can use this alpha and beta, okay, because you can see that this alpha and beta is linked directly to the concentration of the reactant, right? Okay, and basically what we can predict here is we can use this alpha and beta to predict the overall order of reaction. Okay, and when we say that what is the overall order of reaction, it means that this is talking about concentration. Okay, because you see just now at first, right, if higher concentration, the rate of reaction will increase, right, because the molecule has more chances to collide each other. Okay, and we actually can indicate that if this alpha and beta, these two we can use to combine and predict the overall order of reaction. So basically overall order of reaction is alpha plus beta. You see this order of reaction, with respect to A is alpha. Order of reaction with respect to B is beta. Okay, this one you have put 1 star here. The order of reaction, let's say in the future, we give you the concentration of the, we give you the equation and then ask you to find out what is the overall order of reaction. Okay? And the order of reaction need not to be integers. Okay? It can be alpha and beta, it not necessary to be integer. It can be, let's say, rate of reaction between this and this. CA, it can be 0.5, etc. CB can be 1.5. Okay? Let's say if this is the rate of dissipation of A, what is the overall order of this reaction?
2.
Wow, very fast, 0.5 plus 1.5 is 2, Yes. Okay? Now, if you already managed to capture this concept now, okay. Actually, okay, the rate of reaction, it can depend on many factors. Okay, it can depend on the first. It can depend on the rate of reaction. What are the factors that can impact to the rate of reaction?
Pressure.
Very good. Concentration. Anything else?
Pressure.
Just now I said something.
Temperature.
Very good. Temperature. Hey, but in the exam, I cannot write like this. Write the full name of temperature. Because if you put like this temp, I don't know what is this temp. Maybe temporarily. And also catalyst, right? Because why the catalyst can increase the reaction rate? Tell me. Why the catalyst is? This one is from your PIPC.
Lowers the activation energy.
Well done. Lower of the activation energy, right? Therefore, there will be higher possibility that the product will be obtained. And also pressure. Okay, because pressure, it can increase the reaction rate. Okay, let's look at the example 2.1. Okay, this sample 2.1, there are 3 starting material, right? Okay, this starting material, you can see there is one oxygen radical. There is no radical there, I put radical. Oxygen radical, plus oxygen, plus nitrogen. And the product that you have is O3 or ozone plus nitrogen. Okay, write the rate equation for the rate of disappearance of oxygen. Rate of disappearance of oxygen is minus RO2 equal to what? Okay, I'll give you a hint. I only can give you the hint during lecture and tutorial, not in the quiz. So let's say, can you come up what is the rate of disappearance of oxygen? How many species are actually involved in this reaction? 3, yes. Okay, so 3, so what? It will be concentration of this 3, right? Concentration of oxygen, concentration of, oxygen radical, oxygen, and concentration of nitrogen. And then rate constant, yes. Anything else? Okay, that's all right. Yes. Do one thing to take note one thing, Okay. This reaction, let's say, because we can see that is 1 mole of O radical, Radical is mean 1 dot, okay? You know what is radical, right? Because it's unpaired electron. So the stoichiometric number is 1 to 1 to 1. It be 1, 1, and 1 here. Okay, this one I will move slowly, but later on we have an interesting question for you to look through. Okay, so for now, what is the overall order of this reaction? Wow, this one easy, right? 1 plus 1 plus 1 is 3, Okay, even though in your exam sometimes you're so excited, 1 plus 1 plus 1 become 4, I don't know why. Okay, so basically this is the third reaction. Okay, 1 plus 1 plus 1. Okay, so now we already familiar with how we write the reaction rate of given reaction. Okay, so for now we have to move to something that a little bit more interesting, which is elementary and non-elementary reaction. Okay, refer to your lecture note, page 5. Okay, for this reaction, right, elementary, I think you got too much energy already, I need to lower the temperature first. Basically, okay, this is still in the, we still consider the rate of reaction, okay, but we have to understand that the rate of reaction, right, when we look at this equation, okay, for examples, the example 2.1 here, okay, the rate of reaction is because O plus O2 plus N2, it gives you O3 and nitrogen, okay, and this reaction somehow it actually one-step reaction. It means that you plus these 3 together, you get O3 and N2, okay? However, sometimes, right, the reaction, even though you can see all these 3 reactants, but somehow, it can be, you get an intermediate first. Something first, After that intermediate will give you a final product. Okay? So basically, what I'm trying to say is, the reaction that you see, it can be classified according to the 2 different types of reaction. Okay? One is the elementary, second one is non-elementary. So what is the elementary reaction? So the elementary reaction is the reaction that, let's say, A plus B give you C. The elementary reaction is the reaction that C will form in one single step. One single step, Then the reaction is known as elementary reaction. Okay. Basically, the idea is whatever you see this equation, it means that the reaction take place exactly as it's written here. Okay? And the reaction, elementary reaction is always correspond to the stoichiometry. So how this thing is actually correspond to the stoichiometry? Now it's actually, let's say for examples, to consider the reaction, same thing. Coefficient A of A plus coefficient B of B give you the products. Okay, if this is the elementary reaction, when you want to write up the rate of reaction, it actually very straightforward. Okay, so the rate of reaction, it will be, okay, this one you know, minus RA equal to K times CA and CB. So how do we know that? What is the M and N? In this case, right, if let's say is this reaction, we know that is elementary reaction. So if this is elementary reaction, M will be equal to A. B will be equal to N. I standardize first. Okay, so the rate of reaction of this reaction is K C A C B D. Talking A B C until sometimes I confuse already. Don't know A, B or C. Depends on what you want to choose from me. I have A, B and C for you to choose. Okay. So what is the order of this reaction? The total order of this reaction is, well, this one is straightforward, right? The order of reaction is A plus B. Okay. Emphasize on one time. The order of this reaction, provided this is the elementary reaction. So straightforward. Elementary reaction. So basically this is the first type of reaction. What about the second one? The second one, just now I mentioned that, let's say this reaction is not straightforward. Okay? Even though we have A plus B, but somehow before you got this product, right, you may get intermediate. Okay, intermediate first. And after that, after the intermediate, okay, never mind right here. Let's say again, A plus B, you get C. But the idea here is A plus B, it actually get something else first. Maybe D, E, F, etc. Wow, got this one first. After that, this D, E, F, wow, can become C. Okay, basically this is a little bit more complex, right? Okay, because the reaction take place in a series of reaction steps. Okay, you can't tell until you actually have to measure it. Okay, actually you can't tell from the reaction itself. When you see this kind of reaction, you can't tell that this is a non-elementary or elementary reaction unless you can check it from the rate, the order of reaction, which I will show you later. So for this, right, let's say the rate of reaction here, the rate of disappearance of A, same as this one, right? Same, Not to me, it's different, CAMCDN. Okay, but now, because of this reaction takes place in a series reaction step, therefore, in this case, M, it will not be the same as A, N, it will not be the same as B. Okay, let's look at examples of non-elementary reaction. You can refer to your lecture on page 7. Actually, this lecture topic too, you have how many lecture slides? 12 only, right? How many are 20? Okay. Yeah. So 20, I think by 2 hours should be able to cover everything already, huh? So next week you don't need to come to lecture already, right? In that case. No, cannot because you want to see me, therefore I drag a lecture a little bit more, huh? Okay, look at the example of the non-elementary reaction. Refer to your lecture note, page 7. Okay, this lecture note, page 7, this example is such a very interesting example, huh? Because this is the reaction that you make HBr. Okay? Take note on the unit of this, you see, hydrogen gas plus bromine. You get HBr in gas also. Okay, have you ever used bromine? Yes, right, from your POC, Yes, okay. You still remember what is the form that you take from the bottle? Aqueous. Okay, what is the color of that? It's actually brown color, right? Okay, bromine actually is gas. Somehow, how come the one you take is actually liquid? Because we actually dissolve bromine in water. Okay, imagine if, don't know you still remember bromination? Yes, you adding bromine into your compound, right? When you add bromine, if I give you, in order to add bromine, your compound must have double bond, right? Yes, okay. If I give you, this is a compound. Okay, I give you one bromine cylinder for you to check. Wow, you have difficulty. How can I add my bromine gas into my double bond? Okay, therefore sometime when you see the sample that the reagent that you use, you see we already converted to the form that is more easier for people like you and me to use. Okay, just to take note, how easy is your life, you see. Everyone is already prepared. You just open your mouth and chew only. Cannot chew bromine, Okay, this reaction, right, you can see that your rate of formation of HBr, wow, it's very complex, right? The rate of formation of HBr is equal to K1 times concentration of hydrogen, concentration of bromine, the power of half, over K2 plus concentration of HBr and Br. Okay. So for this, right, let's say we can actually draw the rate of disappearance of the reaction. You see, concentration you can actually write in this way also. CH2 also can. Okay? Or you can put this concentration. Okay? This is the example of non-elementary reaction. Why? Why this is non-elementary reaction? Because you can say that if it's elementary reaction, what is the rate of formation of HBr? Let's say in the case elementary, rate of formation of HBr will be equal to what? K C H2 CBr2. Very good. Someone already, you can do this already, get C already. Get C already. Yeah. I want to give you more, so answer more. Okay, so for this, if this is elementary reaction, the reaction rate, the formation of HBr must be like this then, right? Compared to this. So the answer is very straightforward, that this is not elementary reaction because look at this, the rate formation of this HBr is the combination of everything, hydrogen also, bromine, and some more is the product. Okay? Okay, let's look at example 2.3. Refer to your lecture note, page 8. So this reaction is the combustion of methane. Okay. I think you already lost the attention, So I give you 3 minutes to do this question first. And then one of you have to answer me first. After that, I can give you a longer break. The rate of expression for disappearance of methane is K, concentration of methane and oxygen. Is this an elementary or non-elementary reaction? How come? How do we know that it's elementary? Okay, you got 1 mark already, yes. 1 mark already, Because when you want to look at this reaction whether it's elementary or not, you look at the coefficient here. Methane is 1, oxygen also 1, right? Yes. And you need to compare against the concentration of this. Remember, this is the alpha and beta. This one is already M and N. Right? So in this case, you can see alpha is the same as M1. It's actually alpha and beta, right? Yeah, alpha and beta. I want to standardize. Alpha is equal to M, beta is equal to N. Therefore, it is the elementary reaction. Okay? Hannah? I know that this will not this will not be coming out from your quizzes, but because the question will be more on the application, okay? But this is the more the you have to build all the foundation first, because later on the question we have it will be more complex. Okay, so the order of reaction with respect to CH4 is 1. Order of reaction with respect to O2 is 1. What is the overall order of reaction? 2, Okay, well done, So I give you, wow, so long, 15 minutes.
What is the order of reaction?
So come back at 3 o'clock. You can go and have waffle first, but long queue, I was waiting for 20 minutes for one waffle. This for lunch.
Are you guys wearing cheers?
I don't know. I want drink. You don't want?
Huh?
You don't want?
Don't want what?